Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hasif Rifdi, and today I'm gonna talk about gas chromatography, which is on experiment 5. So the contents on this slide, we will be talking about introduction, methodology, analysis, conclusion, and reference. Next, so let's start on introduction. What is chromatography? Chromatography is an analytical tool that is used to isolate and then detect the chemical components of a sample mixture to determine their presence or absence and how or much is the presence of the chemicals. The components of a samples are dissolved in a solvent and vaporized in order to separate the analytes by distributing the sample between mobile and stationary phase. So, chromatography is widely used in quality control, in manufacture of products, and for research purposes, also for safety, which is from environmental to food and forensics. Next, methodology. In this slide, we will be talking about how to handle the sample. First, syringe was rinsed before filling with samples. Make sure there are no air bubbles in the syringe. Then number 2, the syringe was held vertically, needle up, and the plunger was pushed to the required volume at eye level. And excess sample was removed using tissue, so there are no samples remaining on the syringe. Next, during the experimental, we need to switch on the instrument, and we will set the gas chromatography using the condition of 70 degrees for both initial and final temperature and 180 degrees for injection and detector temperature. Retention time for each component was determined by injecting the component sample. Number 4, standard mixture was injected. Retention time was compared and each component presence was identified. Unknown sample was injected and components present was identified. Number 7, column temperature was changed to 100 degrees for both initial and finals. Standard mixture was injected and effect of reducing the temperature was commented during the change of temperature. Lastly, number 8, oven temperature was changed to 140 degrees for both initial and final. Standard mixture was then injected. So next we need to comment the increasing of temperature and the effect.
Assalamualaikum and hello guys. My name is Muhammad Noriman. So I will continue the presentation about Experiment 5 about result, discussion and conclusion of this experiment. So for the result, so as you can see, this is the result of the experiment. So as you can see, the standard mixture of the panel, their retention time is 1.56 minutes, and for N-butanol 1.99 minutes, and for unknown samples, the retention time is 1.54 minutes, and at 100 degree Celsius, the detection time for the propanol is 1.59, and for N-butanol is 1.72 minute, and for 140 degrees Celsius, detection time for the propanol 1.68 minutes, and for N-butanol is 1.70 minutes. So next we move to the discussion. So retention times are differentiated according to the number of carbon, molecular weight, and the volume of the samples. Temperature change during the experiment of gas chromatography effect on time retention and RS. So meaning that the higher the temperature was set, the longer it takes for the compounds to erupt at temperature 70 degrees Celsius, as we see from this result. Standard mixture retention time for 2.0 is 1.56 minutes and N-butanol is 1.99 minutes. The boiling point of 2.0 is lower than N-butanol. So 2.0 has retention time shorter than N-butanol retention time. The unknown sample is identified as true propanol because its retention time 1.54 minutes close to the base retention time true propanol, which is 1.56 minutes. At 108 degrees Celsius, standard mixture retention time for true propanol is 1.59 minutes and N-butanol is 1.72 minutes. At 140 degrees Celsius, standard mixture retention time for 2-propanol is 1.68 minutes and N-butanol is 1.73 minutes. The first compound to be eluted is 2-propanol and the last eluted is N-butanol. So for the conclusion of this experiment, in conclusion, the retention time at 70 degree for 2-propanol is 1.56 minutes and N-butanol is 1.99 minutes. The unknown sample is expected to be 2-propanol since the component retention time is close with the standard 2-propanol dilution. The retention time at 140 degree for standard mixture for 2-propanol and N-butanol show 1.68 minutes and 1.73 minutes respectively. Lastly, the conclude for the whole experiment, as the temperature increase, so the retention time TR will increase and the RS will increase as well. So that's all for me. Thank you.
Assalamualaikum, my name is Muhammad Wafi. In this segment, I will talk about experiment 6, which is high performance liquid chromatography. What is high performance liquid chromatography? High performance liquid chromatography is basically a highly improved form of column chromatography. In column chromatography, a solvent drips through a column filled with an absorbent under gravity. In high performance liquid chromatography, a pump forces a solvent through a column under high pressure of up to 400 atmosphere, which makes it much more faster. It also allows to use a very much smaller particle size for the column packing material, which gives a much greater surface area for interaction between the stationary phase and the molecule flowing past it. This allows a much better separation of the components of the mixture. The other major improvement of column chromatography concerns the detection methods which can be used. These methods are highly automated and extremely sensitive.
Hello, I'm going to explain about methodology. This diagram shows that how to set up the high performance liquid chromatography. How to prepare it? First, weigh caffeine accurately, and then the caffeine transfer into 100 ml volumetric flux, and then the caffeine dilute until the mark with HPLC grade water. The standard solution can be obtained by carrying out a series of dilution of the mixture shaken to ensure the adequate mixing. The solution filtered using the provided filter. The beverage can be found in the refrigerator in the lab. Prepare the coffee sample. How to prepare coffee sample? First, pipette 5 ml of coffee into a clean and dry 50 ml volumetric flux, and then dilute it to the mark with HPLC grade water. Then filter the sample using the provided filter. Rinse the filter by filtering the first 1 to 2 ml of the sample into the waste beaker, and then fill a vial with a prepared volume and label the vial. Prepare the soft drink sample. The soft drink sample that you select is bicarbonate. We must decarbonate the soft drink by pouring it back and forth between two beakers until its bubble cease. Then pipetted 25 ml of the soft drink into a clean and dry 50 ml volumetric flask, and then dilute to the mark with HPLC grade water. Filter the sample using provided filter. Rinse the filter by filtering the first 1 to 2 ml of the sample into the waste beaker. Fill a vial with the appropriate volume and label the vial. This is the result after the conducted experiment. And this analysis of which caffeine standard using mobile phase, reverse phase, what more caffeine, and soft drink and coffee using is reverse phase. And then the pump injector also using the same for the 3 sampling loop. And then the column also use the same capillary electrophoresis. And the detector using the UV Perkin-Elmer series 2000. And then the discussion based on the result, the soft drink sample contained a caffeine by looking at the retention time, which is 1.12 seconds. The soft drink sample contained 35.34% of caffeine. The retention time of caffeine can be determined by using HPLC. While the retention time for coffee sample is 1.19 seconds and only have 32.03 caffeine in the majority of the sample, this result can be determined by the amount of caffeine in the soft drink. There were several steps to be taken during the experiment to minimize data error. First, shake all the solutions sufficiently to ensure the solution for 5 minutes before injection into the chromatography. Then make sure the column is not clogged, caused by precipitation of protein in the column caused during fractionation by the removal of stabilizing agent. Besides that, before and after each sample was injected, the syringe was rinsed and washed to avoid any contamination and other solution that would affect the process. Finally, during the experiment, prevent the production of bubble because it will impact the reading in the column while the measurement is taken. Thank you.
In conclusion, this experiment can determine the retention time of a standard solution caffeine, which is 1.209 seconds. This experiment also can identify the caffeine peak in a soft drink sample, which is 35.34%. Lastly, this experiment can determine the amount of caffeine in soft drink sample using the response factor method, which is 140.71 ppm. These are our references of this experiment.